Hello, this is Trevor. Today we're working on another SSRF lab in Portswigger's Web Security Academy. This time it's a blind SSRF with Shellshock exploitation. So the site uses analytics software, fetches a URL specified in the refer header. Oh, it's blind. That's going to make it hard. Internal server in this range on port 8080. Wow. Okay. All right. Well, let's get started. We need to scan the internal to find one that is vulnerable to Shellshock. Once we find that, we need to exploit it to get that OS user. Sweet. And it said it was in the tracking feature. Let's view page source. See if we get anything here. So it's not shown on the front end. And let's, whoops. What's going on? Temporary project, load. Okay. To load that. Let's see if we get any proxy HTTP history. So we don't get any, and we can ignore this one. We don't see any other requests, but let's send this to repeater and verify the SSRF through the refer header, which I don't even see here. And then we can go about trying to solve this. So burp, let's go to collaborator client, copy to clipboard, and let's throw refer HTTP there. Send that. And let's change this to 3 and pull now. There we go. Sweet. So it is in the refer, and we get that. We need the user agent most likely to attack the Shellshock. So what I notice is that this user agent and this user agent is exactly the same. Let's try changing it to see if we get one. And let's go like this so it's always on top. Yeah. Okay, so that's how we'll attack the other one. The internal one, Shellshock. Well, this is where we'll put our payload to exploit that. So let's send this to intruder. And we need this to be like 192.168.0.1 on port 8080, right? Let's clear. And then here we need the Shellshock. Let's go Chrome, just so I remember Shellshock exploit, just so I remember what that looks like. There we go. So we're going to put boom, boom, like this here. Not the single quote. What I'm going to do, open parentheses, space, open curly brace, space, colon, semicolon, close, semicolon. And then here, I want curl, and then this URL. So HTTP. Do I need spaces? I mean quotes? I don't think so. How will I know what? Let's do this. Let's do slash, and then we'll add there, and then we'll add here. Whoops. I said add here. And then we'll use I think it's pitchfork, no, battering ram. Single set of payloads places the same payload into all of the defined payload positions at once. So if we do a 1 here, we'll put a 1 here. And if we get a response back, we know that the IP of 192.168.0.1 is our target. Okay, so payloads, we'll do numbers from 1 to 254. Step will be 1. I think that's it. Let's send it. And my hope is that we see a response up here for one of these that's vulnerable to Shellshock. We're going to have to do this again in code, which is interesting. So that's done. Uh-oh. Okay. So I messed up somewhere. Let's go, positions. Echo, echo curl. No.
Which phone number, contact, or device do you want
Echo,
to call?
shut up.
Canceling.
Sorry about that. All right, so this is what we want, curl. And we don't need the space is fine. So let's try this attack. Same, everything else. Since it's blind, we shouldn't notice anything different here. I'm following along, but really my focus is up here. Hey, sweet, we got something. All right. Let's see what we got. HTTP request to collaborator 189. Sweet. All right. Now we can go to attack that specific one, 189. And the goal was to exfiltrate the name of the OS user. So right here, we can just put let me make sure we're not going to solve it. Yeah, we have to submit solution. So if I do $, who am I? And this should take the results of this command and append it to the end of the URL. I'm thinking, and we don't need send to repeater. We don't actually need intruder for that. Everything else looks good. Let's send it. Awesome. And there we go. There's the user. Sweet. All right. Really happy that worked out. So let's close this and let's write our script. So our script is going to have to do 2 things. One, it's going to have to send this request iterating through, actually Control Z, this request, iterating through the IP addresses to find one that returns. It'll ask for the input to get the IP address that is valid. And then it'll send another request and ask for the input for the username and then submit that. Sound good? So let me just write that down. Kate. So one, scan internal IPs. Ask for input on which vulnerable exploit IP to get host name, for ask for host name, 5 submit solution, 6 check if solved. Okay, those are our tasks. Sweet. All right, Vim, what is this called? Shellshock exploitation. Shellshock exploitation .py. Let's grab our template. This is a shop, right? Yeah. Okay. So we need to scan internal addresses with this request. So it's a GET request to this URL. Get response, shop.get response URL. Let's see, product URL equals and then we can change the, did I copy, paste? What the heck? It's not letting me copy. Oh, product, question mark, product ID. Product, question mark, product ID equals 1, like that. Product, capital I, lowercase d, equals 1. Okay. Product URL equals shop.base URL plus that. We need to, and can we use get response? The key thing is we need to be able to change the refer and the user agent. And I don't think we can. So let's not use get response. Let's set the refer headers equals, boom, referrer, comma, and what was the other one? Oh yeah, user agent. User agent. Those are the two things we need to set. So let's change them, send the request, make sure it works. If shop dot no proxy. So if no proxy is true, request dot get product URL headers equals headers, just like that. Else request get product headers proxies equals utils dot proxies, and verify equals false. we're not going to, we can't tell anything from the response, so might as well not get it. Let's run this shell shock. I'm going to just copy this. Make sure that, you know, this stuff, information is shown in the request. User agent and refer. Perfect. Now, refer is going to be, we need to loop through. Well, let's set this stuff first, and then we'll create the loop. Let's go to intruder. Refer is going to be the internal IP that we want to attack. HTTP 192.168.0. Let's put IP there. User agent is going to be the curl statement. So here to here. Control Shift V. And then we need to go to the end and put IP here. We need to put an F there and an F here. Empty expression not allowed. Oh, it's because of these curly braces. They need to be doubled up so that Python doesn't think they're... That looks good. And we're going to do for IP in range 1 to 255. I'm doing 255 here because Python won't, it's, I don't know what the right word is, non-inclusive. It won't, so this means the last one will be 254. It'll start at 1, but the last one will be 254. And then here, we're going to do last octet equals input. What is the last octet? And then we'll do string, or no, int this, and then we'll print last octet just so I don't have the error. Okay, that looks good to me. Python. Oh, let's not hard code this. So here we're gonna do parse args collab, and then here we're gonna put args.collab. Okay, that looks good. Python shell shock. We need the URL, which is here. Paste, and we need a burp collaborator for collaborator client. Copy the clipboard. Paste. Let's send it. This is going to be kind of slow. We don't have any threading, so it's going to do it one after another. I think I'm going to need to add threading. Let's go ahead and do that now because what is it on? Curl. It's on 13. But that looks good. I didn't check the user agent. Looks good. Refer looks good. So we want to move all of the action items to def test IP. I don't like that name. Attempt exploit IP. We can't tell whether or not it's vulnerable by the response. So we need, let's change this to a task, and we'll do task single quote IP, task single quote IP, and instead of shop no proxy, we'll put task single quote IP. So we're giving it product. Oh, we need, yeah, task product URL. Do we need, I will define that once. Okay. Task product URL. So the task needs to be, let me just comment that task equals, it needs to have IP, shop, and product URL. Those are the three things it needs to have in the dictionary. Okay, so for IP and range, this. Do we want? Yeah, that's fine. We're gonna create a list of tasks. So tasks equals boom. Task equals a dictionary. We'll do IP with IP. Shop with shop and product URL with product URL. Tasks.append task. We can comment all of that out. Now we're at the part where we need, so we set up the stage for multi-threading. We have a separate function that does what each thread needs to do. And then we have a list of tasks built, ready to go. So we need concurrent futures, which I'm going to have to do that search again. So let's go here. We'll write it. Close this. grep. We'll cd grep -r concurrent. I'll just search that. So we have some down here in XSS. We can use that. So vim XSS event handlers. Perfect. And let's open up our SSRF one, which was Shellshock, that one. We're looking for this part. We don't need to actually save the results. With can refer to num threads. So let's add, let's just do it here. Num threads equals 1. As executor results equals executor submit. This is the function exploit IP for task and tasks for F in concurrent features as completed results res equals F results. I don't really care about the results. So how much of this do I need? I don't know if I can comment all of that out. Let's see what we can get away with. We need to import it there. And do we need, so let me, I took a copy of it and then I'll comment it out. So my question is, will this do what we want? We're just doing one thread to start with, so let's try it. I'm going to Python that. I don't see any errors, which is a good sign. And this is going through, which is a good sign. Sweet. Let's pump up the numbers to, let's go for the whole shebang. 10. Why not? No errors. This is looking good. Okay. Sit back. Let's make sure this is looking good. So here's our request. Let's go this way. We got the user agent, curl, this, 137. That looks good. 5. We don't have any, which is not good. Response. Got a good response. Request. Get product ID. Refer. Uh-oh. This isn't good. Let's send this to, isn't it repeater where we have a good example? Yeah. And it should be the same. Do I not have the port? Proxy. I don't have the damn port. Gosh dang it. I've done that like every time. I forget the port. Refer. Right here. 8080. Okay. Let's end this. Run this. And hopefully we see something here. Let's change this to 1. Just because I don't want to. Hey, sweet. 189. So we'll copy that. Go here. Paste that. Nice. So we've got it. We've got step 1 and 2 done using threading. Let's delete anything we don't need. Last octet, we have that. Now, exploit IP to get host name. Oh, you know what? We can just copy this. Okay, so headers refer task, instead of task IP, we're going to do last octet. Whoops. Last octet. And then here, Arch Collab, instead of task IP, we're going to do last octet. We made it an integer. That was probably a dumb idea. Since we're just putting in strings, we can leave it as a string. Task shop. If we don't need this, shop request task. Product URL. Headers. I'm just going to fix all of this, and then we'll go through and make sure everything else is good. Okay, so we've got this and this, but we don't want last octet here. We want $, boom, who am I? Right? Looks good. And then we'll ask user username, sure, equals input. What is the username? Print username. Okay, if that works, it will take us down to, it's not host name, it's username. To step 4 complete. Let's try that. And it should be the same internal IP of 189. I like this. We're making progress here. Going pretty fast. There we go. It is 189. Sweet. We can go here. Paste that. And then, yes. Quest to collaborator. Copy this. Paste it here. Perfect. So we've got everything down except for submit solution. And then check if solved. We should have something in sight that submits solution. Submit. There we go. So we just need to provide it the solution. Shop.submit solution with username. Shop.is solved. Okay, that should be it. Let's pump this up to 14. Why the heck not? We don't have any logs. Well, I'm not going to run it again. I really should put log.info scanning internal network for vulnerable host. And then here we'll do exploiting host to get username. And then that's it. All right, let's check the latest. Quest to collaborator 189. Copy it. Paste it. We need the username, which is Peter. 43B whatever. We'll paste that. And boom, lab is solved. Sweet. Let's check out. Let's get our banner. There we go. So pretty cool. I like this one. Let's recap real quick. What we did was first we proved that the refer header was vulnerable to SSRF. And we did that by just putting in the collaborator client URL as that refer header, submitted that, and verified that we got a response. Once we did that, in the instructions, it said there was a host we needed to scan 192.168.0.0 on port 8080, and there was a host vulnerable to Shellshock. So we used repeater to intruder to find the vulnerable host IP, and then use that again to get the host name. And then we put all that into code using threads, first to get the vulnerable IP, which host is vulnerable, and then use that again to execute the command who am I and return the results. And then that was it. We got those, submitted those as a solution, and solved this mother. All right, cool one. If you have any questions, definitely let me know. Otherwise, I'll see you in the next one. Thank you so much. Goodbye. Hey, so I'm just going to add this on to the end of the video since it'll be so short, but we just finished all the SSRF labs, and basically all we did for each of them was access an internal URL. That was the result of exploiting SSRF. So I need to find where I can put this. And to be honest, I think this is really the only spot that makes sense to me, right? No account to user access. You would think that this would be a post and not a get. So I'm going to leave it off there. User access to admin access. I guess we could no. I don't know how that would be used here. But this one makes sense. If like there's the file server at localhost 6566, we could possibly use SSRF to view the results of getting that. So I'm going to leave it there for now. Again, if you have any differences of opinion, situations where it would be used that are general. So if we come, if I'm going through the test and I see a spot that I could use SSRF to obtain this, however whatever that looks like, I'm obviously going to do it. I'm not going to limit myself to what's here. But in general, these are the things I'm going to look for when I have this access. Hope that makes sense. All right. Let me know if you have a difference of opinion or think it should be somewhere else or whatever. Thanks.